Good morning, everybody, and welcome to this second part of the webinars of What's New in SolidCAM 2016. In this webinar, we will be showing some of the major changes and improvements within SolidCAM 2016 that I mentioned yesterday. What we consider to be the major improvements are the advanced mill turn solution that I mentioned yesterday. That sort of sounds a bit vague, but I'll go into a bit more detail with it this morning and you shall see what I mean by that. The interactive machine preview, which is an enhancement to both the turning and the mill turn strategies that make it a lot easier to actually set up your tool and your part on the machine. You can see it, how it will appear on the machine itself. There is also the combined operations in iMachining that I mentioned that we will be doing, and I shall show you a demonstration of that. The active fixture avoidance in iMachining 3D, which I will also be doing a quick demonstration on, and the mirror operations on a plane in the coordinate system, which my colleague Ronnie will be doing a separate webinar on next week, I think. Also, as I mentioned yesterday, just to remind you, for the people who weren't at yesterday's webinar, we have other enhancements and improvements within SolidCAM 2016 that include such things as variable depth on the profile that allows you to select several profile operations of several different depths of cut, different face depths in one operation, in a single operation, thus saving time in programming. And also in pocket we have variable levels, so you can have several pockets in the same operation where the start height and bottom of the pocket all vary. You can have several, as many as you like, in there. The only thing that they can't do is be inside each other. That's where it doesn't allow that to happen. Got to be separate pockets. We also have the ability to choose your geometry faster in 16 than previous versions. You can mirror toolpath around the axis, various axes in HSS and 5-axis mode, and we have the drill point removal in iMachining 2D, which is a handy feature. You don't have to, we're not doing any air cutting to get down there. Also, I will be demonstrating that later on in this webinar. Okay, advanced mill turn solution. Well, what does that mean? Well, it's a series of enhancements and improvements in the way that SolidCAM 2016 works now, over and above what had happened in previous versions. So what we will be looking at is not just the things that you will see quite easily as you work through SolidCAM 2016. You will see various changes. Some are obvious. You'll see buttons that have appeared that weren't there before. You'll see icons that have slightly changed from previous versions. But what we're going to look at a bit more here is what's gone on under the bonnet, if you like, and how SolidCAM 2016 has changed the way it thinks, the way it looks at things, and then you will see how that adds up to what we're calling an advanced mill turn solution. I'm just going to show you a few slides now, and then after I've shown you these slides, I'm going to then go on to do a bit of a demonstration of how this looks in the actual SolidCAM 2016. So I'm just going to change my screen if I can. What's happened here? Yeah. Oh dear, where's that gone? Let's change my screen. Bear with me a second. Right, I hope you can see that now. That's the part that I've got open for you. No, that's not what I wanted to do, did I? I wanted to show you wanted to show you the slideshow. I do apologise. My slides slideshow's gone crazy. Bear with me. Right, hopefully. Right, you can see that slide again. Do apologise for that. Okay, in SolidCAM 2016, I'm just going to briefly go through these slides. I'm not going to talk too long about it because we haven't got all day. I know people have got work to do. But the way the VMID, the Virtual Machine ID file has changed, which forms part of your post-processor, we've changed the way it thinks. Instead of having axes on devices, so to speak, we've got devices on axes, which is how it actually is on an actual machine. You will have your tool on an axis. You will have your chuck on a spindle, so on and so forth. So that's how it is now set up, more logically to the way an actual machine is set up. We also have something that I think is great. It's called the Interactive Machine Preview on the VMID as well. This Interactive Machine Preview is available throughout most of the menus within the Milturn package. So you can see it in the VMID file, you can see it in your tooling library, you can see it in your setup. And I shall show you that as we move through. Stock positioning now is mounted on the table as it would be on a real machine rather than on a sub machine, which is not the way it would work in reality. We can now have a interactive machine preview for any machine control operation that we may have created, or you may have created. So if you're doing a machine control operation where it may be you may be looking at changing the part from the main spindle to the sub spindle, for instance, then you've got an interactive machine preview that shows you how that's going to be happening. Drive units within the turning now supports several gear ranges on the same device, spindle, speed, etc., as on a real machine. Automatic selection of the gear according to the speed that the spindle speed that you want to achieve. All is now added in the Milturn module. Interactive machine preview for the tool table, as I mentioned earlier, so you can now see all your tools as they would appear on the carousel or on the turret of the machine, and you can see how they may need to be moved or changed if they're fouling each other, etc. A bit more easy to see. And machine simulation, you can now actually show the actual axis positions all the time. No need to select previous MCOs in order to launch it. And the result of all this is that we now can support even better the more complex Milturn machines because of the way they all set up. And here's an example of some of the machines that we can now model up and support because of the way they work. They work differently to your more conventional machines, such as sliding head type of machines with multi-fixtures on a turret at the end of the machine, like you may have a choke or a center that may be indexable. So very, very complex machines that are coming onto the market these days need supporting by CAM systems, and SolidCAM is at the forefront of supporting Milturn machines. So if you've got even if you haven't got a Milturn machine and you were thinking of buying a Milturn machine and wonder if it can be supported by such things as SolidCAM, then the answer most definitely now is yes, we will be able to support your machine because of the new advances in Milturn. And for those of you who already do have Milturn machines and you're looking at upgrading to 2016, just one important thing to note: because of the way SolidCAM internal engine has now changed in the Milturn, you will notice that your setup needs to be slightly different. Whereas previous versions, as you can see from the slide, in SolidCAM 2015, for instance, we had this scenario where you needed to set up 4 Mach positions. If you had a machine that had 2 spindles and an upper and lower turret, you would have to have 4 Mach positions for each of them relationships. Now, because of the way SolidCAM works, you only need two. You only need one for the back spindle and one for the main spindle, and that's it. So you don't have to have a separate Mach coordinate that points to the upper turret and the lower turret. You just have one for the spindle. So that's a change that will be made. So when you do upgrade to 2016 and you look at your mill turn setup and you think to yourself, well, this looks a bit different, well, this is why. It runs different. The intelligence behind the whole thing is different. Okay, what I'm going to do now is do a little quick example of the part. Now I'm trying to change this. Okay, there we go. Hopefully you can see that part now. And I'm not going to do any machining on here. I'm just going to show you where the menus are and how things have changed here. So the first thing I'm going to look at is the setup, which I just mentioned. If I right click on there and go to edit that to quickly look at that. Here we have a part. By the way, this machine is a twin spindle and twin turret machine, so it's got upper and lower turrets. And you can see by the setup here that we only have a position for the back spindle and the main spindle, one position. We have the stock in a particular position to start off with, so we've got it in the main spindle to start off with, so we can move the stock from spindle to spindle. So if you're starting off in the back spindle, then you can move the stock to the back spindle. The nice button in here is this one here in the right corner, machine preview. I click on that, you can see now that we've got a bit of a better idea of how things are set up. We've got our Mach position here for our part. If I just quickly zoom up there, you can see our part is indeed in the main spindle, which is where I'd set it to. If I was to come out of there and change it to there and have a look, you'll see now it's in our back spindle. So it's dead easy to see, and you'll see the coordinates changed with it. So that's one advantage of the setup. You can see exactly how it is set up. You know, you don't have to sort of have it in your head. You can see it with your eyes what's going on there. Okay. The next thing to have a look at is our tool table. We'll have a look in here. It looks pretty familiar as from where it did before, but one thing that has changed, you've got a save and you've got a save and exit button. These have changed slightly, so you can save your tool library without it exiting, which is sometimes what frustrating when you change an item on a tool and you save it, and then you want to carry on and leave the tool table open to do something else in there. When you save it, it would close and disappear, which used to annoy me, I know that. But you've got the option now of saving it without it exiting, so that's handy. Let's have a look at our mounting of our tool. We've got, as you can see on the left hand side, an upper and a lower turret library of tools. But let's have a look at our mounting of our tools. So I'm going to pick on this particular tool at the top here. It's tool 1, it's a turning tool, and it's in the upper turret. In fact, no, I'm not going to do that. I'm going to pick the lower turret because the lower turret is an actual proper traditional tool carousel, tool turret, indexing tool turret. So I'm going to pick on this turning tool that's in the lower turret, and we'll have a look at the mount. If you look on the screen there, you can see it appear. So this is the tool. So we'll have a look at the mounting. I'll click on the mounting, and where before you just would see a tool there stuck in fresh air, now you can see it in relationship to all the rest of the machine. So you've got the whole of the machine here. You can show as little or as much of the machine as you want. So we've got the tool here stuck up here at the upside down on the lower turret. So there's the mounting of the tool holder, and there's your tool stuck on it there. So you can show as much and little as you want. We can click on the rest of the turret here and see the turret itself in isolation. I'm trying not to move this around too much to make it dizzy, but there's the tools in relationship to each other, so you can see that whether anything's likely to cause a collision or whatever. And then you can see the whole machine. You see the relationship with everything and where it all belongs. You can see the upper turret and the tool that happens to be in there at this particular time. And what you can also do, as you when you've got this window open, you've got your tool table open, I can flick through these tools and you can see the turret indexing as you would see it, in real life on the machine. I think it's a fantastic addition to the graphics and the way we can see the machine in as if it was in real life. So that's in the tool table. So look at the actual operation perhaps that we may want to do. I'm going to open this operation here. This is it's the upper turret on the back spindle, and it's about to do a face turning operation. So let me open that actual menu operation. So we're looking at that. What we can do is look at the machine view as to what's about to happen here. Make sure that things are as we expect it to be. And again, it's showing you the part itself. We've got this is the situation as it is at the start of this operation. So we've got the lower turret parked up out of the way, minding its own business. We've got the part itself in the sub spindle as we expect, and we've got the tool in position at the start position, about to start this operation. So that's where we are there. So you can see visually exactly what you expect. We also have a option to update the stock at this point, where the stock in the spindle at this point is already being machined in the main spindle. So the stock that you see now isn't the stock as it actually will be. So let's update the stock. So we can press that, and you can see that the stock has updated itself to how it would actually be, having been machined on the previous operations on the main spindle. Very, very handy thing. Okay, what I shall do now, I'll just move on. I was going to create a tool, but I'm aware that time is going on, and I'm aware also that you haven't got all day. And I've got some iMachining to show you slightly shortly. Sorry, so I don't want to take too much of your time. So I'm going to swiftly move on with the slideshow, and switch screens again. Okay, that's where we were in the machine setup. Also in the mill-turn enhancements, we've improved the way the channel synchronization works. I'm briefly just going to show you a few slides here, just so you can see. I'm not going to go into any great detail. The channel synchronization has changed slightly, giving you better control over the various operations that's happening, so that you can synchronize your back spindle and your upper turret with your front spindle and your other turret. And to that end, you can add a new workpiece for multi-stock work, so you can show the two pieces on the machine at the same time. You've got the part in the front spindle, you've got the part in the back spindle. You can see them both at the same time in the various states. You can also see problem areas, such as areas that are in the same space of the machine at the same time. So you can see the potential collisions that may be likely to occur. So you can see that before you've even looked at the machine. You can see it on the synchronization, where it will tell you what's happening there. And from that, what we can now do is do a machine simulation of the synchronized machining process. As you've reordered things and timed things together, you can then simulate the new synchronized machining operations. All the other simulation operations, your host CAD and your normal one will just show it as it appears in the tree order, as one operation at a time. But when you run machine simulation, it'll run the synchronized machining order, which is what everybody's been wanting. So that's a great enhancement in my view. Okay, now we're going to move on to iMachining. again, iMachining is one of the major modules within SolidCAM. It has taken the world by storm. For those people who are watching who don't have iMachining or don't know what it is, it's a fantastic addition to SolidCAM and is our high speed stock removal strategy, if you like. It's a fantastic time saver. It can save up to 75% in time of removing material on certain jobs. It's always going to save time, or pretty much always going to save time on any job because of the way it works. But for those of you who are familiar with iMachining, you'll want to know what's changed in here. So one of the main things that's changed here is automatic removal of material left by a pre-drill tip, optimized finishing of 2.5D features, so you can it will hold off a wall and a floor for finishing either of the other, and so it's got an intelligent avoidance of the previous cuts. But for me, the most advanced thing that's been changed is in iMachining 3D, where it will actively avoid the fixtures. You just define what fixtures, where the fixtures are, tell it how much you want to avoid it by, 5mm or whatever it is, and it will do just that. It'll just skirt round the fixtures, and then you can move the fixtures afterwards, and it'll remove the material from where it was. We also have in iMachining 2D the option of combining operations. So you've got rough and finish together in one operation, which is a handy thing, time saver once again in programming. And from that, you've obviously got the option to rough and finish, then finish, and then finish after finish if you want, because you can go in there with a smaller tool that the larger tool couldn't fit. So you've got lots more options within iMachining 2D to finish the part. Also in iMachining, you've got the addition of choosing whether to finish the floor in the traditional contour style or in the iMachining style, let the iMachining toolpath continue as it would normally, or choose a contouring finish. And once again, as we saw earlier, you've got the option to automatically avoid your fixturing, which I shall demonstrate shortly. Let me once again change screens. It's not the quickest thing to do on here. Show my other screen. Here we go. And I'm just going to close down the part that I had open previously. Let me just move this menu out of the way that you can't see. Close that down, and I'm just going to open a iMachining part, a mill part here, and this is a quick one just to show the drilling tip removal. So here we have a part that's basically like a hollowed out brick. So I'm going to machine this pocket out here with my iMachining strategy, but before I do that, I'm going to drill it. So I'm just going to do a quick simple drilling operation there, and that's it, away it goes. And you can see it's a traditional drill with a 118-degree drill point, and it's left that drill point in the bottom there. As so far so familiar. So in this operation here, in our iMachining operation, as ever, I've used a pre-drilling, used that pre-drilling up to drop into it as you would normally. But this time, as you've probably guessed, there's a bit of a difference. There's our part with our pre-drilled hole in. As soon as I start to simulate this, the iMachining drops straight in the bottom there and just starts taking that drill point out automatically itself. It knows it's there by the information that's been given from the previous drill. So it's just milling down there. I'll speed it up slightly. So it takes the drill point out and then opens the part out to finish it in its normal way. Okay, so that's drill point removal. That's pretty straightforward. So far so good. The other thing I'm going to demonstrate in iMachining is, I'll tell you what I'll do whilst I'm there. I'll show you the toolpath. Let's open that back up again. In my finish, here's our option of choosing the contour or iMachining option. I choose the iMachining option. Let's save and calculate that. It took its time there. I think it's because of using the other monitor. You'll see that it's, hide that. You'll see that it's got the traditional iMachining morphing spiral toolpath that if you've got iMachining already, you'll be familiar with that toolpath. But I might not want that toolpath showing on my finished pocket. I might not want all them little marks there that we can see. So we can choose now to use the contour strategy to just finish it with. So I'll save and calculate that again. You can see underneath the roughing toolpath where you've got the spiral moves, you can see the traditional step over of your contouring toolpath that you would normally get if you were machining any standard pocket. So you can choose the finish type that you may want to achieve on the bottom of a pocket there now. Okay, moving on from there then, I shall now open a 3D milling iMachining part, and on this part we, as you can see, have got several fixtures on there, and this is where I'm going to show you how the fixture avoidance works. We've got one operation, that's all we've got set on here so far, so I'm going to be roughing this part out. I'll not rough it all out because it will be here all day, but you'll get the idea when I show you the simulation shortly. Here we have our normal operation, but what you've got in your geometry, we've got a new little bit of information here. We've got fixture collision protection, and you've got a fixture clearance area that you may want to select. Got 2 millimeters here, which I suppose is pushing it a bit. So you've got to be pretty good with your clamp position. If your clamp position's pretty regular, you know, it can only go in one place, then you can be tight to it. But if you can move it about a bit, you might want to give yourself a little bit more clearance than 2 millimeters. But that's all you need to do. You need to tell it that how far you basically want to switch it on, and then you want to give it a certain value, and then of course you define your fixtures in your setup, whichever one it is that you've decided to use. My fixture, if I right click on there, I can wrong one. Show my fixture. Okay, it's not. Let me just run this operation and we'll see it. Simulate it. There's our fixtures on our part, and iMachining is just going to avoid it. We've told them where they are, which the fixtures are, and it's just actively going around them and then machining the rest of the part. I'll speed this up because it's quite a long process. So it's just completely ignoring the areas that are covered by the clamps, and it does everything else it can. And if I turn this right up, we hopefully will get to the end of the process, and you'll see that the area, as I say, under the clamps has been completely avoided. So what you would do next, obviously, is move your clamps or put the clamps somewhere else, and then just run a iMachining operation a second time, and it will only, an iMachining 3D operation that is, and it will only machine the material that's got left behind by where the clamps used to be. So that's a excellent addition, I think, to iMachining 3D. Okay, that's pretty much it really for this second webinar. I hope you enjoyed some of the new additions there. I think they're pretty good actually, especially that fixture avoidance there. I think that's superb. The thing is with SolidCAM 2016 is there's been so many enhancements added to it in this year. There's been over 80 added enhancements, some more obvious than others, and because there's so many, I'm not going to bore you with sitting here and talking about them and showing you slide after slide. We'll be here all day. So what we've decided to do is to run a series of courses, and I'm just going to put up some details of that. If you are interested in attending one of these courses, we're running a series of one-day courses basically, and I've called it update training because pretty much that's what it is. We're wanting to bring everybody up to date with all the changes that have been made in SolidCAM 2016, because there are quite a few. So if you want to attend one of these courses, dates, availability and pricing, if you can please contact Louise on our office number, which is 01226 241 744, or you can email Louise at louise@solidcamuk.com. I'll leave that up for a few moments so you can all take note of that, and I'll take any questions. If anyone wants to ask a question and text me a question, I'll sit here for a moment or two and see if anyone's going to ask me a question. I think the only question to ask really is as I said yesterday, is when is it going to be available? Now, yesterday I said that it was going to be made available straight away after the webinar for anybody who has attended the webinar. We were just in discussions with that yesterday. It looks like it'll be available to you guys next week, and then we'll roll it out to everybody, I think, the week after that. The reason why we have been a bit reticent at rolling it out is because of the changes that are made in the mill turn. For customers who already have mill turn machines, it's going to mean quite a big change for them in the way they work. So we want to be sure that everybody is aware of what needs to happen, and we do need to speak to them specific customers so to make sure that everything's aware, so we have a smooth transition from previous versions up to SolidCAM 2016. Okay, nobody seems to have typed a question for me, so as long as you're all happy, I'm happy. I hope you were pleased with what you saw. I hope you will upgrade to 2016. It looks like it's going to be a great version of SolidCAM 2016, as I say, especially with the additional support for the more complex mill turn machines. If you were thinking of buying a mill turn machine and wondering how you're going to control it, well, I think hopefully that'll have given you a bit of comfort as to how we can support it now. Also, in iMachining 3D, the fixture avoidance strategy there, I think, is a fantastic addition. Okay, well, there's no more for me to say then, except for good morning, and hope you all have a good weekend, and I'll see you next time. Thank you very much.